Hello friends, in this video we shall discuss with respect to NTA UGC NET of electronic science paper which was conducted on 27th January 2025. In this part 1 video we shall discuss from question number 1 to question number 25. If you have attended this paper, make sure you're going to comment your score in the comment section. And those who are preparing for June 2025, make sure you're going to go through the solution video and you'll be getting a fair idea as to what sort of questions they'll be giving and how to answer these questions in a stipulated amount of time. Hello friends, this is Arun Kumar here. I welcome you to my channel Craving Gyan. For my small effort, I expect a big thumbs up from you. Let us move on to the first question. In the first question, what they are given is match a list 1 with list 2. EEG, ECG, EMG, electrocardiograph. On the list 2, they have given brain activity, heart activity, activity between cornea and back of the eye, nerve and muscular activity. We know that this EEG is for brain activity and ECG is for the heart activity. So for B it is 1 and for A it is 2. Which and all options you can eliminate means option 2 and option 4 can be easily eliminated. Now EMG is for nerve and muscular activity and electrocardiograph is for activity between cornea and back of the eye. So based on this, if I am going, then I will be getting a C equals to 4 and D is 3. Nothing but which option it is going to follow means option 3 is correct. Option 3 is correct. Let us move on to the second question. In this, what they have given is a VTH will be determined when all the. Now look at the thing. So this question is somewhat tricky. Say suppose if they have asked with respect to the Thevenin's impedance or Norton's impedance, then you can get into these two options. Nothing but voltage sources is considered to be a short circuit and current sources need to be considered as an open circuit. So these things are valid. These things are valid when you are going to find the Thevenin's impedance or the Norton impedance. So option 4, if you are opting, it will be a wrong one. See, you will be having a bilinear network consisting of independent current sources or voltage sources, and you will be having a resistors, inductors, capacitors connected in some fashion. At the end, you will be having a load. That load you are going to remove and then you are going to measure the potential, and that potential will be your Thevenin's voltage or the open circuit voltage. So all the sources are kept as it is, nothing but which option is going to follow. Option 1 is correct. My dear students, don't get confused. In the third question, what they have given is, look at the things. This is an op-amp based problem, and this is a question on inverting summer or inverting configuration adder. In this, they have given the two inputs, so 2 volts and 2 volts connected through 4 kilo ohms and 4 kilo ohms, and the feedback will be having 10 kilo ohms. Here, they have not specified the value of non-inverting battery potential. So you can take it as 0 volts and then you can solve it. Now look at the things. In the case of inverting configuration or in the case of summer, what will be the output? The output will be always 180 degree out of phase when compared to the input. V naught equals to negative sign you want. That negative sign is going to indicate 180 degree phase shift. So the first option, if you are getting into, it will be 10 volts. So plus 10 volts they are given. So first option can be easily eliminated. Now, in the problem, they have not spoken with respect to VCC and minus VEE. So you take some higher value and then you are going to solve. So what is the output voltage expression you are going to get? V naught, which is equals to, what is the formula? Minus RF times of V1 divided by R1 plus V2 divided by R2. Now you tell me what is the value of RF they have specified. The value of RF will be equals to, see, no need to represent that kilo. Why I am not representing that kilo means RF is in the order of kilo ohms, even R1 and R2 is also in the order of kilo. That kilo and kilo is going to get cancelled. What is the value of V1? 2 divided by 4. V2 is again 2 divided by 4. R2 is 4. Now, this is half and half is going to consider 1. So the value of V naught will be equals to minus 10 volts. The value of V naught will be equals to minus 10 volts. Which option you are going to get? Option 4 is correct. This question, if they would have specified the VCC and minus VEE as, say suppose 5 volts or 9 volts, this V naught equals to minus RF times of this formula would have not been valid. Why? Virtual short would have not been valid, right? So when virtual short is going to be valid, when V plus can be taken to V minus. So these things are very important when they have given the problems based on op-amp based configuration, right? So for this third question, V naught equals to minus 10 volts, you're going to get option D is correct. In this fourth question, what they have given is, see, this question is based on Colpitt's oscillator. What they have specified is, we have to find the values of C2 and we have to find the value of beta. And this beta is referred as the feedback factor. Now look at the things. If they have given 2 capacitors and 1 inductor, this question is based on Colpitt's oscillator, that too in the feedback. Right? In the feedback, you'll be having the tank circuit. The tank circuit they have specified. If it is an Hartley oscillator, then they will be giving 2 inductors and 1 capacitor. Here you will be having inductors and capacitors. See, in the Hartley oscillator, the L equivalent is given by L1 plus L2 and C is C only. But in this, you will be having, or you are supposed to write the equivalent capacitance. That equivalent capacitance I am going to call by C, which is equals to C1 C2 divided by C1 plus C2. C1 C2 divided by C1 plus C2. So this is the equivalent capacitance you will be having. Now what is the frequency? What is the formula for frequency in the case of Hartley and Colpitt's oscillator? For both you will be getting the same thing, that is F equals to 1 divided by 2 pi root LC, where L is L only but C is what? C1 C2 divided by C1 plus C2. So substitute, they have given F equals to 1 megahertz. 1 mega means what? 1 into 10 power 6, which is equals to 1 divided by 2 pi into write L and C under the root. What is the value of L they have specified? The value of L is a 20 milli. 20 into milli means what? 10 power minus 3. And you tell me what is the value of C, we don't know. That is the thing we have to find out, right? So here look at the things, square on both sides, you will be getting the value of C. Squaring on both sides and then cross multiplying, then this C I am going to send it on the other side, which is equals to 1 divided by the squaring I am making. So what I am going to get? 1 divided by 4 pi square I am going to get. This square and under root is going to get cancelled, that is a 20 milli. 20 into 10 power minus 3. Now look at the things. This 10 power 6, if I am kicking on the downside, on the other side, what I am going to get? 10 power 6 square will be 10 power 12. This 10 power 12 and milli, what I am going to get? 10 power 9. Sending on the upper side, it will be 10 power minus 9, right? So, when you are solving 1 divided by 4 pi square into 20, how much you are going to get? Means C equals to 1.26. C equals to 1.26 picofarad. That's it. You got the value of C, which is equals to 1.26 picofarad. Substitute the C in this equation, you are going to get the value of C2, right? So 1.26, which is equals to, tell me what is the value of C1 you are going to get? 4, right? 4 into C2 divided by 4 plus C2. 4 plus C2. Cross multiplication. 4 6 24. 2. 4 2s 8 9 10. Then 4 1s 4. Then 5. Plus 1.26 times of C2, which is equals to 4C2. Send this term on the right side. What you are going to get? 5.04, which is equals to 4 minus 1.26, which will be 2.74 C2, right? So upon solving the value of C2, you are going to get roughly 1.85, and you are going to attach that pico. Because initially you have removed the pico, at last you are going to fix the value of pico. That's it. 1.85 picofarad you are going to get. So this is the value of C2. And what is the option you are going to get? Option 3 is correct. Why? 1.8 roughly equated to 1.85, right? See, these things have made use of calculator. Without calculator, if you are going to use, means at that time you are going to get approximately 1.8, right? Go through the options. Each and every options are varied apart. Now, what is the feedback factor? Feedback factor beta I is given by, what is the formula? C2 divided by C1. Similarly, in the case of Hartley oscillator, what is the value of feedback factor? If you are knowing, comment your answers in the comment section, right? So beta equals to C2 divided by C1, which is equals to 1.85. No need to write again pico. Why? Numerator pico, denominator pico, both is going to get cancelled. What is the value of C1? Students, tell me, no? It's 4 picofarad. Now, upon solving the value of beta, you're going to get a 0.45. Upon solving, you're going to get the value of beta as 0.46. You're going to get, take it as 45, right? So, with this, what is the value of C2? I'm going to get 1.85 picofarad. And what is the value of beta? I'm going to get a 0.45. So, based on this, I can go with the option 3. So, option 3 is the correct answer for this one. In this fifth question, what they are asking is match the following. Look at the things in the list one. They have given a binary as well as a hexadecimal and a decimal one. They are going to ask the equivalent binary or decimal. Get into the first option. See, 111 right? So let me take a 111 to the base 2. Now 0 into 2 power 0. Plus 0 into 2 power 1 plus 0 into 2 power 2 plus 1 into 2 power 3 plus 1 into 2 power 4 plus 1 into 2 power 5. What is 2 power 5? It is 32. What is 2 power 4? 2 power 4, how much? 16. Plus what is 2 power 3? It is 8. Right? So 32 plus 8 is how much? 40. 40 plus 16 is how much? 56. 56. This is in decimal. This is in decimal. So for A it is 3. For A it is 3. Now second one is a D3 dot A. D3 dot A to the base 16. Now let us try to write the equivalent decimal. Right, because this number seems to be very much high. Let us try to convert it. Right, so this is dot. Next, E is how much? 15. 15 divided by 16 plus 3 into 16 power 0 is what? 3 into 1, nothing but 3 plus C is 12, D is 13. So 13 into 16 power 1 is what? 16 only. So when you try to solve, you are going to get a 211. When you try to solve, you are going to get a 211. Then look at the things. 15 divided by 16 is a 0.875. So it is a 0.875 in decimal. In decimal. Hexadecimal value will be less, decimal will be high. So for B it is 4. Next, 34.75. 34.75. Let us try to convert into equivalent binary. Now, before decimal, after decimal, how to solve? You should have a fair idea. Now look at the things. 34. It is a 2 17s. Remainder is 0. Next, 2 8s 16. Remainder is 1. Like this you have to solve. Then you are going to get 2 4s 8 0. Next 2 2s 4 0. Next 2 1s 2 0. Start writing from top to bottom. So what is the value you are going to get? 1 0 0 1 0. Right? Next, after decimal you have to solve. How to solve after decimal means, look at the things. 0.75 multiplied by, what is the number system you are using? Binary number system. So it is a 2. So 0.75 multiplied by 2 is how much? 1.5. So 1 is there. I am going to write it 1. Remaining terms you take. That is a 0.5. 0.5 multiplied by 2 is how much? 1.0. 1. You got the value 0. So stop. Start writing from top to bottom. 1 1 is there. Replicate 1 1. So So 34.75 is what? 1,000,10.11 or 0.11. So for C it is 1. Next 101010, such a simple thing. 101010, right? So it is a 2 power 0. Next 2 power 1 is what? 2 plus 2 power 2. Next is what? 2 power 3. What is the value of 2 power 3? It is 8. Next 2 power 4 into 0, 0. Next 2 power 5, you are going to write. What is the value of 2 power 5? It is 32. What is 32 plus 10 is what? 42. 42. Right? So based on this, if I am solving, what is the answer I am going to get? So when you try to solve, you are going to get the answer as fourth option is correct. Right? I hope you understood with the solution. In the seventh question, what they are asking is, they are asking what is the value of sum and carry. They have given the test cases in the waveform, right? They have given the test bench kind of thing. Now, we know that full adder is a combination circuit which is going to accept 3 inputs and it is going to produce 2 outputs, that is sum and carry output. Now, look at the things. In order to understand, I have written the truth table. In this, carefully when you observe, when all the inputs are 0, a sum is 0 and carry is 0. When any one of the inputs are 1, nothing but either A is 1 or B is 1 or C is 1. In this cases, you will be getting sum as 1 and carry as 0. Next, look at the things carefully. Look at the things carefully. When 2 inputs are high, at that time you are going to get a carry output as 1 and sum equals to 0. 2 means what? 1, 0. Sum is 0 and carry is 1. And in the next case, when you carefully observe, when all the inputs are high, at that time nothing but 3. How are you going to represent? Sum is 1 and carry equals to 1. So let us solve the first option. See, in the first one what they are given is, for the pulse A, when all the inputs are high, sum equals to 1 and carry equals to 1. So sum equals to 1 is correct and carry equals to 1 is correct. So for pulse A, this is valid. Next, for pulse B, 0, 1, 1. 0, 1, 1, nothing but 2 inputs are high. So whenever 2 inputs are high, at that time what is the thing you are going to get? Whenever 2 inputs are high, at that time what is the output you are going to get? Right? So at that time you will be getting a sum as 0, and carry as 1. So B can't be. Next, go through the C pulse. When C input is 1, rest of the things are 0. When C input is 1, rest of the 2 are 0. Nothing but when one of the input is high, at that time you are going to get a sum as 1 and carry as 0. You are going to get sum, nothing but summation, you are going to get a 1, carry output as a 0. Correct. So for pulse C also it is valid. And get into pulse D, 0, 1, 0. There also you should get, see, 0, 1, 0 is this case, same as C pulse. You are going to have sum equals to 1 and carry equals to 0. Sum equals to 1 and carry equals to 0. So pulse D can't be. So pulse A and C is correct. Nothing but statement, first statement is correct and third statement is correct. So based on this, if I am solving, option 3 is going to be followed. In this 8th question, what they are asking is, we have to find the transfer function for the given block diagram. See, you can reduce the block diagram if you are knowing the simplifications, or else straight away you convert into signal flow graph, apply Mason's gain formula, you will be getting the answer. Now look at the things. Here you will be having the feedback, that too in a negative configuration. So what is the equivalent for this one? It will be G1 divided by 1 plus G1 times of H1. And what is the equivalent for this one? It is G2 divided by 1 plus G2 times of H2. Now, these two things are in series, nothing but you are going to multiply and then you are going to solve. Say, consider this one as x. At that time, the overall what you are going to get is x divided by 1 plus x times of H3. That's it. You will be getting the answer. One more method is make use of Mason's gain formula and then you are going to solve. In this, what you are going to do is you will be having the summing block and you will be having the takeaway points. So, these are all summing points and this is a takeaway points. So, all the summing blocks as well as the takeaway points you are going to represent by a node. And the gain things you are going to represent on arrows. That's it. So, you will be having one node and you will be having the other node. The gain you are going to represent by arrows, that is a G1. Then again you will be having a takeaway point and then a summing point. Gain you are going to represent on arrows, G2. You will be having a takeaway point, you will be having a takeaway point and then this will be your C of S. Right? Represents the H1 and H2 also. Now look at the things. This is H1 with negative sign. So minus H1 and you will be having this one as H2 with negative sign. Overall, one more feedback is there, that is H3. That is H3 with negative sign. That's it. You're going to make use of Mason's gain formula and then you're going to write C of S divided by R of S and that will be your transfer function. Before to that, let me write the nodes also. Sorry, let me write the loop gains also. The first loop gain is, or the first loop, let us consider this one. It is G1 times of minus H1. So I'm going to write it as a minus G1 times of H1. I'm going to write it as minus G1 times of H1. The second loop you will be having, that is G2 and minus H2. So the second loop you are going to have minus G2 times of H2. Right? Next, again one more loop is there. One more loop is there. If they are not specified the loop gain, these values are 1. These values need to be taken it as 1 because in multiplication multiply by 1 and in addition or in the subtraction you are going to add it 0. Right? Next, you will be having the third loop. You will be having the third outer loop, that is L3, which is equals to G1, G2 and H3. G1, G2 and minus H3. These are all individual loops. Now, go through it carefully. Is there any two non-touching loops? Yes. There is no any common node between the first loop and the second loop. Right? So, L1 and L2 are two non-touching loops. So it is minus G1 H1 minus G2 H2, you have to multiply. So minus into minus will be plus. So it is G1 H1 G2 H2. Or write G1 G2 H1 H2. Anything and everything of your choice is valid. Next, write the transfer function which is given by, what is the expression you will be having? C of S divided by R of S. C of S divided by R of S, which is equals to. See this question, please don't make use of Mason's gain formula. Straight away you solve using block diagram. I am telling you the alternate way. If somewhat complications are there, then straight away if you are solving by converting, then it will be very much easy. Now this question without solving you can solve it. How? Once I will solve it now. Let us get into the options and then you can eliminate it. Now, in this, first write the first forward path. What is the first forward path from R of S to C of S? It is G1 G2 into 1 minus. Is there any loop that is not touching? Is there any loop that is not touching this G1 and G2? No, right? So you have to write 1 minus 0. So 1 minus 0 is what? 1 only. So no need to represent. No need to represent. Divided by 1 minus of. You have to write the individual loops. 1 minus of these three things are there, and all these three things are with the negative sign. That negative and this negative is going to become a positive. 1 plus what? G1 times of H1 plus G2 times of H2 plus G1, G2 and H3 plus two non-touching loops you have to write. That is G1, G2, H1, H2, right? So this is the transfer function what you are going to get. Option 1 is going to be followed. Now look at the things. If they have specified a 3 non-touching loops, then you are going to write it as minus and then you are going to solve. Option 1 is going to follow. Now how can I eliminate option 2? You please observe, in the forward path there is no H3 term. There is no H3 term. So option 2 can be eliminated easily. And in the third option you see they have given all these things with negative sign. So third option can be eliminated. In the fourth option they have given a positive, but this term they have given it as negative. So fourth option can be eliminated easily without converting or without solving. Looking at the block diagram, you should be in a position to answer. How much time will be taking to solve? Not more than 10 seconds, right? So for this 8th question, option 1 is going to be followed. 9th question C. LVDT, linear variable differential transducer, very important, is used for the measurement of velocity of an object, no. Displacement of an object is correct. Temperature difference, no. Voltage and inductance of a coil, no. So for this LVDT, the corresponding option is second option, nothing but we are going to measure the displacement. What is the sensitivity in the case of LVDT? Means it is 40 volt per millimeter. That much of high sensitivity your LVDT is going to offer. Very important. Next, in the 10th question they have given the mathematical form of Ampere's law is. See, whenever I am speaking with respect to Ampere's law, it is curl H equals to J plus dou D divided by dou T. First J is for conduction current and the dou D divided by dou T is for displacement current. Very important, right? For Maxwell's equation if they are asking, and if you are not in a position to answer, my sincere advice is don't give this NET exam. Very important, right? So this curl H, we know that it is J plus dou D divided by dou T. What is the significance of this Ampere's law? Very important. So in the integral form if I am writing, it will be H dot dl, which is equals to I, nothing but option 3 is going to follow. In the 11th question, what they are asking is, they have given the differential equations kind of thing. For an LTA system, they are asking what is the response H of S. What is the expression for Y of T they are asking. Now look at the things and let me take the binomial Laplace transform equation or equivalent of it. So what is the thing you are going to get? For D square you will be getting S square, then Y of T will be Y of S plus 3 times of S into Y of S plus 2 times of Y of S you are going to get, which is equals to X of S, which is equals to X of S. Now look at the things. Let me take Y of S terms common, then what you are going to get? S square plus 3S plus 2, which is equals to X of S. What is the response you will be having? H of S, which is equals to Y of S output divided by input, which is equals to 1 divided by send this term on the other side. What you're going to get? S square plus 3S plus 2. S square plus 3S plus 2. Option 2 is going to follow. Now look at the things. What are the factors for S square plus 3S plus 2? The factors will be S plus 2 is one factor, S plus 1 is another factor. S square plus 2S plus S plus 2. When you are solving, you are going to get S plus 2 and S plus 1. See, for this one it will be e power minus 2t when you take the inverse transform. Then for the second term it will be e power minus t. Some coefficients you will be having, that coefficients you call it as m and n. When you try to solve, you are going to get which option as correct. Second option is going to follow. Second option is going to follow. What about the first option? Look at the things. S square, they have given it as minus. So first option can be eliminated so easily. What about the third option? Same scenario, s square minus they have given. What about the fourth option? Fourth option, you see, s square plus 2s plus 3 they have given, right, which is wrong. So based on this, if you are solving, the option 2 is going to follow. 12th question, consider the thyristor, that is SCR structure. This question they have repeated a number of times. How you are going to turn on the thyristor means, see, across anode to cathode you apply some potential, and that potential is not enough. So what you are going to do is you are going to inject the gate pulse. Before injecting the gate pulse, what is the situation? Say suppose if I am given some sufficient voltage, then also this junction J3 will be forward bias, no problem. Junction J1 will be forward bias. What is the problem? J2 will be in a reverse bias state. So what we are going to do is we are going to make use of the gate pulse in order to make it forward bias. The moment you apply a positive gate pulse, it is going to forward bias. It is going to forward bias, right? Now, once when the SCR is turned on, the gate pulses is going to lose its control. Gate pulses is going to lose its control. But in the case of triac, it is not the scenario. So junction J1 and J3 will be forward bias and junction J2 will be reverse bias. So in order to overcome it, what you are going to do is you are going to inject the gate pulse. Very, very important. 13th question is based on oscillator. See, we know that in the case of oscillator, we are going to make use of positive feedback, and in the case of amplifiers, we are going to make use of negative feedback. In the case of oscillator, we expect a phase shift of 360 degree or 0 degree. But in the case of amplifier, you will be having a phase shift of 180 degree. In the case of oscillator, your amplifier structure will be giving a phase shift of 180 degree, and that one will be overcome with the help of a tank circuit or the feedback circuit, right? You'll be having Hartley oscillator, Colpitts oscillator, Hasse phase shift oscillator, Weinbridge oscillator, crystal oscillator, and whatsoever, right? So in the case of oscillator, which are all the statements are true means loop gain should be unity. What do you mean by loop gain means? You're going to talk about A beta should be equals to 1. What is the practical value means? It is slightly greater than 1, nothing but 1.02. So A statement is correct, B statement automatically it is wrong. Now, as I told, in the case of oscillator, we expect a phase shift of 360 degree or 0 degree. In the case of amplifier design, we expect a phase shift of 180 degree, right? Anyway, two amplifiers you are going to connect in cascade, and then you are going to get a faithful amplification as well as the phase shift you are going to remove. So, statement A and D is going to follow, nothing but option 2 is correct. In the 14th question, they are asking us to find the static error coefficient, that is Kp, Kv and Ka. Kp stands for proportional error, Kv stands for velocity error, and Ka stands for acceleration error. Now, how we are going to find the values of Kp, Kv and Ka? What are the equations? Kp equals to limit as s tends to 0. Straight away you write g of s. That's it. So this is how we are going to find the value of Kp. Similarly, how we are going to find the value of Kv? Kv is a limit as s tends to 0. S times of g of s you are going to get. That's it. Then what is the value of Ka? Which is a limit as s tends to 0. S square times of g of s. Now look at the things carefully. Compare type and input. Compare type and input. Type you are going to compare with respect to the input. Say suppose when type is greater than input, type is equals to input, type is less than. What do you mean by type? Means see the s power n, that n indicates the type, right? S power n, if I am writing, that n indicates the type, right? How many poles are there at the origin? That is the type of a system. Say type is greater than input means output is 0, nothing but error. Type is equals to input means you are going to get some value that is constant. Type is less than input means straight away you write infinity. Straight away you write infinity. Based on this you solve, well and good, right? Now Strictly speaking, you are supposed to write a g of s times of h of s, but in the question they have given unity feedback system, so I have taken h of s as 1 and then I am going to solve, right, which is equals to a limit as s tends to 0. Now see carefully, you notice it is 0.1 times of s, but in question they have given 0.15. That 5 it should not be, it should be s only. When you substitute this s as 0, what you are going to get? 50 into 1 plus 0, you are going to get nothing but 1 into 10 you are going to get, right? What is 50 divided by 10? How much you are going to get? 50 divided by 10 is how much? 5 you will be having. 5 you will be getting. So what is the value of Kp? Kp is 5. Straight away, which and all the options you can eliminate means option 1 and 3 you can eliminate. Now, what is the value of Kv? Kv, which is equals to a limit as s tends to 0. You are going to have the s term multiplied by some constant you will be having. That constant is not a 0 one, right? Now look at the things. This is not infinity. When s is tending to 0, so this term you are going to tend it to 0. Some terms are there that I don't know. 0 multiplied by anything, but not from infinity. It should not be infinity. 0 multiplied by non-infinity, you are going to get it as what? A 0. So straight away I got Kv equals to 0. Which option? Option 2 is correct. Similarly, try to solve for acceleration error, that is a limit as s tends to 0, s square times of some term you are going to have. That s square, now look at the things, denominator s square, you try to take it as common and then you solve. You are going to get this equation as 0, right? So say suppose here you are going to take it as s square as constant, 50 divided by, what you are going to get? 1 divided by s plus 0.1 into 1 divided by s plus 10. Now look at the things. This s square and s square is going to get cancelled. S is tending to 0. S is tending to 0 means, look at the things, 1 by s, 1 by 0 means what? Infinity you will be having. That 50 divided by infinity is what? 0. Now look at the things, s you are tending it to 0. 1 divided by s, 1 divided by 0 is what? Infinity. Again you will be having 1 divided by 0, infinity. Overall denominator is infinity. 50 divided by infinity is what? 0. That's what I am telling. Straight away you can write or you can tell that Kp value is 5. Kv value is 5. Sorry, Kv value is 0. Ka value is 0. Option B is correct. Or option 2 is correct. 15th question, you see, I have discussed in the microprocessor revision video. In 8086, which of the following are machine control flag? You refer to the video I have explained in detail.
Now, if I am talking about the flag register, as I discussed, we are having two variants of flag. The first one is status flag and the second one is control flag or machine control flag. So this is very, very important. N number of times in UGC NET exams they have asked which one falls under status flag and which falls under control flag or machine control flag. We know that direction flag, interrupt flag and trap flag falls under machine control flag. The status flags are overflow flag, sign flag, zero flag, auxiliary flag, parity flag and carry flag.
You watched the video, right? Now tell me the answer. Zero flag is a status flag. It is not a control flag or a machine control flag. Direction flag is a machine control flag. Sign flag is not a machine control flag. Trap flag is a machine control flag. Interrupt flag is a machine control flag. These three are machine control flag. B, D, E. Option. Which option is going to follow? Option 1 is correct. And in the microprocessor revision video, I have told this question will be asked n number of times. And this question has asked n number of times in UGC NET exams. I have specified and this time they have asked the question. 16th question. Capacity of Gaussian channel. Right? Next, source coding 4G Satellite communication. See, satellite communication, it is going to make use of 4 gigahertz to 30 gigahertz. So for D, it is 2. For D, it is 2. Straight away, you are going to get the answer as option 2 is correct. Now, 4G uses OFDM. 4G uses OFDM technique. Next, source coding is Huffman coding, and the capacity of Gaussian channel is Shannon-Hartley theorem. Shannon's Hartley theorem. Very, very important. So based on this, if I am solving, option 2 is correct. 17th question, you see, match a list 1 with list 2. Monostable multivibrator, bistable multivibrator, clamping circuit, and Schmitt trigger. Schmitt trigger, you will be having a positive feedback, and it is used as a comparator kind of thing. You're going to have UTP, LTP, that is upper triggering point and lower triggering point. So these things are very, very important. And the clamping means it is a DC level translator. DC shifters is what? Clamping circuits. You'll be having two variants, positive clamper and negative clamper, right? Positive clampers are the one which is going to shift the signal towards the positive side, and negative clampers are the one which is going to shift the signal on the negative side. You'll not be having the double-ended clampers. Very, very important. So for C it is 2. For C it is 2. And for D it is 1. And for D it is 1. Now look at the things. See, when you are operating on a weighing scale, right, the moment you insert a coin, your weight will be measured, right? Whatever the object you are going to place, that particular object weight will be measured, and the measuring will be for a particular duration. Say suppose in a coffee vending machine, you try to fetch a coffee, or you try to fetch a tea, or you try to fetch hot water, right? The particular duration is fixed. And the particular duration is fixed, and that is achieved with the help of a monostable multivibrator. A triggering pulse is given. That's it. It will be having a single state. But in the case of bistable multivibrator, you will be having what? You will be having two stable states. That is, a flip-flop is a bistable element. Example, flip-flop is a bistable element. So based on this, if I am solving, so for A it is 3. So for A it is 3 and B it is 4. Based on this, if I am solving, option 2 is correct. 18th question. Arrange the following in a decreasing order of transmission power. Right, highest to lowest they are asking. See, in the case of AM, you are going to transmit what? Message signal as well as the carrier signal, right? Here the carrier signal power is, or the carrier signal power is very, very high when compared to FM. FM offers very much a lesser power transmission, or the losses will be less, as well as the transmission power required is less in the case of FM. But it is not the scenario in the case of AM. In the case of AM, simple AM, power required is very, very high. Usefulness is 25%, worst case 33.33%. Right? Next, efficiency is 33.33% if you are going to make use of sinusoidal, but if you are going to make use of a square wave, you will be having 50%, practically not possible. Right? See, the power in the case of AM is very, very high. Next is what? DSBSC. Next is which one? VSB. See, don't get confused with respect to VSB and SSB. See, in the case of SSB, you will be having either upper sideband or lower sideband. Either one you will be having. But in the case of VSB, you will be having complete upper sideband, but vestige of lower sideband. Nothing but portion of lower sideband. Or complete lower sideband you will be having, but vestige of upper sideband. So in the case of VSB, the power consumption is more when compared to SSB. At last you will be having FM. Try to arrange the option that is going to follow is option 1 is correct. Right? That is, first it is AM, then it is a DSBSC, then it is a VSB, then it is SSB, then it is FM. In the 19th question, you see, in the case of diac, how you are going to represent diac means, see, it is something like this. But in the case of triac, you will be having something like this. So you can either provide the input signal or you can give the current. You can inject the current or you can withdraw the current. So based on that, the particular diode will be turned on or off. In the diac, you will not be having that gate pulses. You will not be having the gate pulses. This IGBT is a combination of BJT and MOSFET. IGBT is a combination of BJT and MOSFET. Very, very important. In the case of SCR, you will be having a configuration which is something like this. Right? You're going to provide a gate pulse and then you're going to realize. Right? So based on this, if I'm solving, option 4 is correct. Nothing but look at the things. In the case of SCR, it is unilateral thyristor. Right? In only one direction it is going to allow. Right? And whenever the thyristor is in the on state, a gate is going to lose its control. Next, IGBT is which one? Bipolar mode MOSFET. Next, triac is which one? Bipolar or bidirectional triode thyristor. Unidirection is which one? Right? Comment. Next, in the case of diac, it is also bidirection, but you will not be having the gate pulse. Very, very important. This 20th question, they are asking us to find the physical address. You referred to my microprocessor fast track revision video. There I have explained in a clear-cut manner how you are going to find the physical address. See, this physical address, if you want to calculate, it is given by the segment register. The segment register value multiplied by 16 in decimal or 10 in hexadecimal. Both are same only. Plus offset address you are going to take. See, segment register you can take data segment, code segment, stack segment, extra segment. But most of the cases you try to make use of data segment, code segment and extra segment. You can't make use of stack segment directly. Offset you can make use of SIDI, SPDP, anything and everything of your choice you can make use. Then the physical address is given by, look at the things, what is the segment address? 1005 multiplied by, each and everything is in hexadecimal, right? So multiplied by 10 plus offset, how much you are having? 5555. Now look at the things, how you are going to write 10050. Simple, 10050 plus for this you are going to add 5555. Each and everything again I am going to repeat, it is in hexadecimal only. 0 plus 5 is 5, 5 plus 5 is not 10, it is A. Then again you will be having 5, 5, 1 in hexadecimal. The suitable option that is going to follow is option 2 is correct. This is how you are going to find the physical address. Very, very important. I have tried to explain in a microprocessor fast track revision video. In 21st question, what they are asking is, they have given the current expression, they are asking us to find, or they are asking us to write the equivalent transconductance equation. So we know that the transconductance, that is GM, is given by dou ID divided by dou VGS. Also, what they have specified is the drain voltage what they have applied is greater than the saturated voltage. Right? Now look at the things carefully. Now differentiate this equation. Dou ID divided by dou VGS, straight away I am going to write it as GM, which is equals to see this mu n times of Cox into W by L is constant. Mu n times of Cox into W by L is constant. I have written as it is. Now VGS term is here. X square differentiation is what? 2x. Again you have to differentiate dx by dx is 1. So like this, if you are doing, what you are going to get? 2 times of VGS minus VTH into dVGS divided by dVGS is 1 only. This 2 and 2 is going to get cancelled. So what is the value you're going to get? GM equals to mu n times of Cox into W by L into VGS minus VTH. VGS minus VTH. Now look at the things carefully. This mu n times of Cox into W by L into VGS minus VTH is already there in this expression. Call this as equation 1. Send this to this side. One more VGS minus VTH, send it in the denominator. What is the thing you are going to get? GM, which is equals to what I am telling. See, you will be having mu n times of Cox into W by L into VGS minus VTH into VGS minus VTH divided by 2. That VGS minus VTH divided by 2, send it on the other side. What you are going to get? You are going to get it as 2 times of ID sat. 2 times of ID sat divided by VGS minus VTH. You are going to send it on the other side. What you're going to get? VGS minus VTH, right? So this is the expression for transconductance. That is 2 times of ID sat divided by VGS minus VTH. Option 4 is going to follow. Option 4 is correct, right? Such a simple question if they are asking, and if we are not in a position to answer, then we will be definitely out of race, right? So I hope you have answered these questions. In the 22nd question, what they are given is they are asking us to write the equivalent expression. What they have given is they have given in terms of SOP. Now look at the things. How can you tell it is SOP expression or POS expression? Means this summation indicates it is SOP expression, and you have to group for ones. If they have given POS, then that is a product of sum. At the time you have to group for zeros, right? We know that SOP is a functionally equivalent to POS. How SOP is functionally equivalent to POS, already I have made a detailed video. You please go through it. Now look at the things. All the cell numbers also I have mentioned. We are going for a gray code configuration, not binary. Why? Single bit change. Power dissipation you are going to reduce, right? Power consumption you are going to reduce. 7, this 7th cell, 9th cell, then 10, 11, 10, 11, 12, 13, 14, 15. So all these things are I. All these things are I. You have to write the equation, that's it. See, grouping 2 things will be a pair, 4 nibble, 8 octet, then 16 word, like this you have to going for grouping. Now look at the things. This 1 I can group it. This entire row I can group it. What is the equivalent value? It is AB. It is AB. AB plus. Now look at the things. Next grouping, this what is common? A is common, B is changing from 1 to 0, so you should not write. Which is not changing, we have to write. So 1 1. 1 means what? A. 0 if it had been there means A bar we are supposed to write. So it is A. Then in this 2 columns, which is common? Last element is common. Last element is common. What is that? D. Is it complement or uncomplement? Uncomplement, right? So it is D. Plus, again we have to group these 2 things. What is common? 1, nothing but A. Between these 2, 1 1 1 0. Which is changing? D is changing, but C is not changing. So we have to write C. Whether it is complement or uncomplement, it is uncomplement. So it is a C. Plus 1 is there, you should not group it as a redundant one. Adjacent cell, can you able to group it? Yes, I can able to group it. So what is common? B is common. Is B bar or B? It is a B only. So it is a B. Next, it is a 1 1. 1 1 means what? Which element it is corresponding? CD. So it is a B C D. So this is the expression for Y. Y equals to this term. So these are the minimal expressions. What do you mean by prime implicant, essential prime implicants, and what is the minimal expression? Each and everything I have made a detailed video. If you have not watched that video, links I am going to give on the description, or else you can click on the I button. In 23rd question, what they are asking is, they are asking us to find what is the output expression, nothing but what are the contents of accumulator, right? And this programming is microcontroller 8051, right? How can you tell it is 8051 or microprocessor? Simple. Look at the things. You're going to make use of swap, right? Complement and RR, move, that too with hash, right? So these things will be telling that this code corresponds to 8051. Now what they are telling is the value that is a CD, you're going to copy it to A. So A register is loaded with CD 1100 1101. Rotate right accumulator by 1 bit position. If I want to perform 4 bits right, means see in this microcontroller 4 times you have to write that RRA, RR, like that, not triple R, man. So like this you have to perform. But in the case of microprocessor 8086, it is very much easy, right? How many times you want to rotate, you can specify then and there only, right? Right side if I am rotating, then it will be 110 and this 0 will commence it over here. 0 1 1, this 1 will commence it over here, so it is 1. So what actually I am going to do means like this I am going to perform, like this I am performing. So this is the rotate right the accumulator by 1 bit. Next, what they are specifying is a complement. What do you mean by complement? If I am saying true, you say false, or if you are saying true, I say false. That is, we both are complement to each other. Similarly, if I am having 1, replace by 0. If I am having 0, replace by 1. One's complement, right? So you are going to get 0 0 0 1 1 0 0 1. That's it. Next, what is the fourth instruction we are going to execute means a swap. What do you mean by swap? Means interchange. Swap means interchange the position, that's it. What is the thing you are going to interchange means this nibble position you are going to interchange. This nibble position you are going to interchange. When you interchange the nibble position, what you are going to get? 1001 0001. Nothing but what? 91H. 91H. Which option? Option 4 is correct. Which option? Option 4 is correct. So this is how you are going to calculate, right? Able to follow? In the 24th question, what they have given is they are asking, they have given the test cases. For which case output y equals to 1 they are asking. Look at the circuit what they have given. In the first case what they have specified is S1 and S2 both are open. Both are open. Then what they have specified is, say suppose if they have given A equals to low. If I am specifying A equals to low means see if I am giving 0 over here. Now both are open means whatever the 5 volts you will be having, that 5 volts will be driving to the gate. Driving to the gate means what? Here you will be getting 1, here also you will be getting 1, here you will be getting 1, here you will be giving 0. What is 1 and 1 given to the AND gate? You will be getting 1. For rest of the cases output is 0. So 1 AND with 1 is 1. Rest of the cases it will be 0. Now look at things carefully. 1 0 given to the OR gate is 1. Complement of it will be 0. Again I am going to repeat. For OR gate to be enabled, either one of the input, at least one of the input should be high. For AND gate to become 0, at least one of the input should be equals to 0. Remember these things carefully. I got output equals to 0, but what is the thing I want? Output equals to 1 I want. So option 1 is wrong. Option 1 is wrong. Next, in the second option you see what they have specified. In the second option you see what they have specified. See, S1 and S2 both are open. Same scenario. S1 and S2 they are open. Open in the sense means what? You will be getting 5 volts. That logic wise high I have specified. Now what is the value of X they have specified? They are giving it as 1. They are giving the value of, they are giving this value A as I. They are giving this input A as I. If they are giving the value of A as I, look at the things. 1 and with 1 is 1. This 1 given to the OR gate is what? 1. Complement of it will be 0. Complement of it will be 0. So here you are going to get 0. Here also you got 0. But what is the thing you want? I want output is 1. So second option is also wrong. In the third option, you see what they have specified is S1 is open. Okay. S2 they are making it close. S2 they are closing. The moment they are trying to close the switch, then this ground will start propagating to the ground to the gate, nothing but 0 and 0 over here. Right? Then A is low. A is low. Now, one of the input is 0 for an AND gate. What is the output? 0. All the input should be 1, then only output is 1. But for OR gate, at least one of the input is high, means finish. 0, 0 given to the OR gate, you are going to get the output as 0. Complement of it will be 1. Complement of it will be 1. Right? So option 3 is correct. Let us verify option 4 also. S1 is closed. Now look at the things. Here what they are specifying is they are going to interchange the switch position. The moment when I interchange the switch position, S1 is closed. S1 is closed means what? Here you will be getting a 0, here 1, 1. What is the value of A? A is I. Now, what is the output? 0. 1, 1 given to the AND gate, it is 1. 0 OR with 1. Don't ever tell 0 plus 1. So it is 0 OR with 1 is what? 1. 1 complement you are going to do. Why? Bubble is there. So you are going to get output as 0. So no any multiple answers you will going to get, but only the option that is correct is option 3 is going to follow. Able to understand? In 25th question, what they are asking is, for a stack pointer in the case of 8051, it is of 8-bit wide. It is not of 16-bit wide. Right? Your stack pointer, register, accumulator, nothing but A, B, or registers R0, R1, R2, R3 up to R7, all these things are 8-bit wide. Only your DPTR is of 16-bit wide. Next, when a chip is reset, the register is initialized to 07H, not 00H. Right? So C and D are contradictory statement. So first option can't be. Next, your pointer of the internal data RAM is pointing up to 00 to 127. Nothing but 002. It is pointing to 00 to 7FH. Very, very important. 127 in decimal. Right? It is equivalent to 7FH in hexadecimal. So A, C, E is correct. Nothing but option 4 is going to follow. Hello friends, so far we have discussed from question number 1 to question number 25. I hope you have understood with the solution video. If you have followed with the solution video, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. For the test series you can make use of cravinggyan.com. Hope so the solution video will be very much helpful for you. Make sure you're going to watch the second video which will be available at the end screen. Thank you friends, all the best for your exams.